Alrighty, folks. So, welcome. Good morning. We left off last time talking about lava, and I sort of haphazardly added a few slides of something I've been meaning to do, and I just want to go start there and sort of correct a couple things that I said as well. So, I'm just going to call this Mount Bromo. You see that it does have another name as well. We're on the island of Java in the Indonesian islands. And it's about the blue lava, okay, because it isn't really lava. That's why I put it in quotes now. It's sulfur gases, and we talked about that. Sulfur mining going on in the area there. But just like I said, a little clarification to what's actually going on. So there's magma very close to the surface, you know, because it's a volcanic area. And what happens is it heats the sulfur deposits that are there over 1,000 degrees Fahrenheit. And that melts it, essentially. So that leaks out at the surface, and because of the temperature change, it's not exactly going through a phase change, but it emits this, it combusts into this blue flame, and along with emitting some of those lovely gases as well. So that's the blue flame. But then, because it is molten sulfur and you're on this on a volcano, a slope, it flows. So it's not lava in the most technical sense, as you know. It is a single molten mineral or element. But it is not lava. So, just wanted to clarify that. But I still hold that it looks pretty freaking cool, regardless, lava or not. And the thing I was reading said it can shoot fumaroles, which is a word I haven't introduced into our lecture, but probably is mentioned in your book. These little jets, really. And they can shoot upwards of 15 feet into the air. I don't think it said meters. I think it was feet. Presumably, he was not in that space. They were in a slightly safer, for lack of a better word, area. So, while this is under lava features until I move it, maybe I'll move it to the everything else category at the end. You'll see when we get there eventually. All right. Now, changing gears slightly, I want to talk about the anatomy of a volcano, and I'd like you to draw a very sort of first-grade volcano on your notes. Sort of an upside-down ice cream cone-looking thing, all right? And then we're going to take a bite out of the ice cream cone and leave a crater at the top. I apparently was quite prone to do this as a child. I would, while I still had ice cream in it, I would bite off the bottom of the cone because I really liked ice cream cone more than I liked ice cream, I think. And, of course, then the inevitable leak out the bottom and so on and so forth. So we want to make that kind of cone. And actually, that'll start us with our very first word. When we talk about volcanoes, we refer to the mountain, the volcano, as a cone. Okay? So the volcano itself, the hill itself, is a cone. That bit of the ice cream cone that you just bit off is what they call the crater. So again, referencing a handful of Hollywood movies or whatnot, you know, when you see these people at the tops throwing various things into the volcano, they're at the rim of the crater, you could say. The next thing we want in our diagram is the center pipe, okay, which is called a vent or a vent pipe. Now, yeah, they've got all these little offshoots on there. This one's a little more basic than most, but we just need one right now. And then that vent pipe goes down to something that's not labeled on here, but we're going to call it a magma chamber. That pool of magma underneath the volcano. We're making this sort of a very closed system, okay? got a single pool of magma feeding a single volcano on top of it, just again for educational purposes kind of thing. All right. Make your drawing nice, neat, and clean. Of course, that magma came from somewhere at some point, some other crack or vent or da-da-da-da-da-da-da. All right. But we're just keeping it simple. So you've got magma chamber, vent, pipe, crater, and cone. 4 things. And that is our anatomy of a volcano. So we got a couple things going on here. We got a foreground and a background in our image. And we'll look first in the foreground, in the front. And we have ourselves a crater. Again, been using this picture 20-some years. I have no idea what volcano that is. But it came from Plummer, McGeary, and Carlson. I can tell you that because I see that that's from C.C. Plummer down there. So I know what book it came from. I want you to picture that sort of like a funnel, because in fact, if you use just the tiniest amount of imagination, you could even see maybe the beginnings of that vent pipe. It might just be bad shading, okay? But if you picture a funnel stuck inside of there like you were making that baking soda volcano, again, back in 1st grade, 2nd grade, whatever, that was always a good thing to have in the top, a nice solid place to put everything. Now, behind that, we have a very picturesque, perfectly round lake. And I don't know how many lakes you've seen from above, but they're not usually that, round. Especially with those nice steep cliffs around it and so on and so forth. What that actually is a collapsed volcano that happened to fill up with water because they're in an area where they receive a lot of precipitation. It's called a caldera. All right, not all calderas are full of water. I want to make that clear. A caldera is a collapsed volcano. You'll see some images in some next couple of slides eventually that show what's going on. But basically, it's sort of the last hurrah of a volcano. The magma chamber empties out, or just potentially extremely eruptive explosion. Whole thing just collapses in on itself. Over time, as we've indicated, it's a low spot. It's a depression. It can fill up with water, and they quite frequently do. And as we said, they're quite picturesque. Your senior year of geology, well, basically the summer before your senior year of geology, that you have to go do what's called field camp. And field camp, kind of like band camp, not quite. A lot more drinking because you're in college. And geologists are just horrible for that. So it's spotty. And they take you out to the desert and the high altitudes and just, this was the 90s, so they just kind of left us there for, be back at when the sun starts to go down kind of thing. Get in the van or we'll leave you. But I've got some memories, and one of my memories is that we were going to a caldera, and we were all excited. We're like, cool, a collapsed volcano, very, very cool, very, very cool. And so we drove, and we drove, and we drove, and finally they pull over to the side of the road, and we get out, and basically there's just, looks like here, if you're on Route 90, and you got, farm to one side, farm to the other side, but with a lot less green, okay? And so we get out, and we're waiting for them to say something, and they can kind of figure out that we really didn't know it, why we were there. So very slowly, he sticks his arm out, teacher, and very slowly spins around in a circle. He's like, "You see those mountains way out there?" I'm like, "Yeah." He's like, "All right, follow them around." Well, Lord only knows how many miles out was this ring of mountains around us. We were standing in the caldera. It would not have fit in one frame. Okay, these things they were massive. They can be massive. All right, so again, when we show you some of this stuff, it's really kind of picked for hey, this fits on a slide, and so on and so forth. We talk about with volcanoes how time has we got to think in geologic time, so on and so forth. Well, we also need to think on Earth level scale. Okay, these things can be massive. And even, a lot of people lucky enough to go to Hawaii, and they say, oh yeah, I know I'm standing on a volcano. Or you look at Iceland. Iceland is arguably, good but bigger than the Hawaiian Islands put together. There's a lot of them, but it's big. Well, you got to think about the base still. Okay, that's the part that's sticking out of the water. So these things can be massive. I know that's a different type of volcano than these superficial ones here, but just trying to get an idea of scale. So the reason I'm talking about this is, again, distance is kind of hard to judge. Let's call that a couple miles, okay, in the background. This more than likely was the same pool of magma. Just a fresher manifestation. It filled back up at some point. All right. These magma chambers don't stay empty for long. There's a weak spot there. If there's more magma in the area, it's likely to bubble in over, again, a fairly long period of time. For whatever reason, it just manifested itself in this new volcano. We certainly see some calderas coming back to life, so to speak. Crater Lake, may not be able to pull up a visual image of that, but you've probably heard the name. In the center of Crater Lake is something called Wizard Island. All right, it's a teeny tiny little spatter cone. We've got a picture of it. We'll see it in a little bit. So, caldera is a collapsed volcano.
Because I used to live in Crater.
Really?
Yeah.
Okay.
In Germany, there's one where a meteorite hit the Earth.
Okay. All right.
50 million years ago.
Yeah.
And so it also looks like it, but not being filled with water. It's not then a crater.
Yeah, no, we do use that word interchangeably, at least over here. It'd be interesting to hear what they call it, the hole in the top of a volcano over there. But yeah, and I think most people, when you say the word crater, they're thinking of an impact crater for sure. But that is so cool that so was there just, like an odd house here or there, or was there an entire subdivision or town in this crater?
It's in the whole region.
It's big, big, big.
Yeah.
Okay.
And I used to have my apprenticeship like 500 meters from where they believe the impact.
Wow.
And they have a stone actually that created from that impact.
Hunk of it. Okay, that's cool. Yeah, they do. We've got a couple. You saw the one, the Diablo crater, Diablo meteorite. We showed back when we first started talking about that. Oftentimes the locals will salvage something that did that. Sounds like yours was way, 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 way long ago. The dinosaurs had to have collected that one probably. But that is so cool. That is so cool. Not very many people could say they live in a crater.
Well, if they're anything like that, they probably thought it was shiny and put it in.
Well, yeah, exactly. If no thumbs though. There's the whole thing. They have to pick it up with their mouths and so on and so forth. But some dinosaurs, I'm sure, did collect things, especially towards the end when they got more and more bird-like, supposedly. I'm not a big fan of that whole dinosaur bird thing, or bird dinosaur thing more so. I don't believe those are dinosaurs hopping around in the trees out there. All right, the Cascade Range. Let's get back on task here. The Cascade Range is North America, our active chain of volcanoes. And yes, I said active. Now, that's one of the things we want to talk about, not at this exact moment, but I keep need to reminding myself because I don't think I have a slide about active, dormant, and extinct. But it's something I always want to talk about. So active. What does that mean? Well, it means in human remembrance, more or less, is what active means. So they talk in the video we watched the other day about Mount St. Helens. They talked about Mount Lassen going off 100 and some years ago. Okay, that's still what we consider to be active. Again, geologic time, bigger time frame, larger time frame than we have. So as you're staring at this, some of these might sound familiar. Many of them you probably thought, I know I did, that they were just mountains. Mount Rainier, it's just a mountain. Well, Mount Rainier is a volcano. These things are, I would say safe to hike, for lack of a better word. Obvious, mountaineering safety issues aside. If they were rumbling about, certainly the park would be closed that day. Mount St. Helens, you could go there and wander around, okay? And yes, even though, 1980 was really recently in its history, and there's been some smoke and whatnot over the last couple decades, but they will let you go. You guys have all heard of Yellowstone, right? Yellowstone has a giant pool of magma underneath it. That's why all that cool stuff is there, okay? And they have earthquakes about I don't want to say once a week, but a decent amount of earthquakes. And one day that park is going to blow itself into oblivion, and every reindeer, bear, moose, and not squirrel, but human. Squirrels will probably run. But please don't let that stop you from going there, because it is an amazing place, okay? Amazing place. You don't not go to Florida because they might have a hurricane, right? You still go to Florida and just pray that they don't have a hurricane the week you're there, kind of thing. If you ever get the chance, go see this stuff, okay? It's very cool. Yeah, there's a doozy out there. There is a doozy out there, and I haven't been paying as much attention to it as I should. But it doesn't look like it's going to hit mainland, but a handful of islands, yeah, not good. Not good. So, Cascade Range runs through 3 of our West Coast states. It goes into Canada, all right, up into British Columbia there, and it sort of peters out as we go down into California. California's not really known for their volcanoes. What are they known for instead?
Earthquakes and fault lines.
Earthquakes. And what?
Fault line.
Ah, all right. Well, the fault line, yep, and then the earthquake. So, what we've got going here, not to use the word manifestation twice in a lecture, but is a different manifestation of the same issue. He mentioned a fault line. You might have heard of the San Andreas Fault. Well, what that really is, what we've really got going on here is a plate boundary, all right, where the North American plate ends and the Pacific plate begins. And we'll get to plate tectonics eventually, but we got to talk about a little bit of it right now, because that is the reason that these are here, all right. And what's basically happening is that we've got, because of geography, because of topography, the lay of the land, we've got one interaction happening where the volcanoes are, and another type happening where the earthquake is. Earthquakes are when the plates slide side by side, right? We're getting the volcanoes here because one plate is being pushed underneath the other plate. And we have a special word for that I don't have a slide for right now. It's called subduction zone. You can spell subdue, right? So turn subdue into subduction. The subduction zone. What's being subdued or subducted is the oceanic plate. It's being pushed underneath the continental plate. For those of you at home that can't see my hands, it's very important kind of to see my hands. I've got my 2 hands, my fingers out straight and kind of like they're bumping into one another, but one hand ends up going underneath the other hand. So one hand rides up on top of the other hand. And so at this boundary, okay, the oceanic plate is being subdued, and so it's going down and it's remelting. I'm now wiggling the fingers of my bottom hand. Maybe I'll have somebody film me later. I don't think I will, though. But so that stuff, my wiggly fingers here are melting. And that is a source of magma very close to the surface. But that's not all, folks. Because what are we? We're underwater, right? This is an oceanic plate. So going down with all that rock is a whole bunch of water. I got any fry cooks here? Really? No SpongeBob's? I was a SpongeBob for a very long time.
I'm a master of the grill.
All right. So, what happens? Maybe you don't. Maybe you still know. YouTube videos might show these poor souls. What happens if you get a little bit of water or ice crystals in a fryer?
Grease fire.
Boom! I see a lot of various hands going boom or some yikes faces. Grease fire, not so much, but it can bubble up like crazy. What's happening is your water is going straight from liquid to gas. What's even worse though are the ice crystals. That's when you get the pops and the pings. It's going from solid to gas. All right, which I think releases a lot more energy. Again, chemistry isn't my biggest thing here, but it goes crazy. Okay, and I have seen fryers almost boil up and go over. That's, I don't want to say worse than a grease fire, but oh my God, cleaning that up is not fun. So all that water's going down with this rock. It's mixing in with the molten rock and going straight to gas. So what we have then is not just a whole bunch of molten rock, but a whole bunch of pressure building up underneath this. And I want you to notice where these volcanoes are. They're not right on the boundary where the continental plate ends and the oceanic plate begins. They're a handful of miles in. And think about going back to my hands. Where are my fingers at that I'm wiggling? They're right about my first set of knuckles down there, right? So that's where all that stuff is boiling up, bubbling up, a good bit under. So that's why the Cascade Range is there, okay? Because of something called a subduction zone. I've now actually taken a good couple minutes to explain what's going on in a subduction zone. So even though there's not a slide for a subduction zone, responsible for a subduction zone.
So over millions of years, we may see new mountains out that way.
Well, we got them now. You mean just more different ones, or?
Yeah, more different ones. Like new
Sure.
ones will eventually form.
Yeah, I mean, as long as the plates keep moving in the same way that they are, which we have no reason to assume they would switch, but they could, you know. But yeah, for sure. Some of you can picture things really well in your heads. Imagine well, here, you don't have to imagine. If you go off up to the northwest and start ringing around to over where Russia is, all right, you've got the Aleutian Islands, another volcanic chain. The difference here is that the plates are pulling apart. And this is more like a cut on your arm or your leg, okay? You rip the skin open and the blood comes out. All right, we've ripped the crust of the ocean floor open. The magma is coming out and bubbling up. So we have more volcanics, but for a different reason. So this sort of horseshoe of red dots and yellow diamonds that you see there is called the Ring of Fire, even though, as I just said, it kind of looks like a horseshoe. I don't know why they didn't go for horseshoe of fire. That's kind of cool. But it is what it is. It does go down. You see this bit of land at the bottom, or Deception Island. That's Antarctica. All right. So it does go down and around in Antarctica. I guess that's the ring they're going for there. This is the capital THE. Okay, the most volcanically and earthquakedly active place in the world. Nearly 3/4 of the Earth's volcanoes and earthquakes are centered around the Ring of Fire. The second most active doesn't really appear, but is in the upper left-hand corner of this slide here, around the Mediterranean. All right, and I can't spell Mediterranean either. Good luck with that. But that is the second most active, and they call it the Circum-Mediterranean Belt. All right. Another name for the Ring of Fire is Circum-Pacific Belt. Circum, as in circumscribe, circumcise, to go around. Okay, go around. So, so the Circum-Mediterranean Belt, and this is where all of your, if you grew up reading your mythologies and whatnot, this is where the majority of your village-obliterating volcanoes of lore are at. We see Etna showing up, Thera, Vesuvius is in there somewhere. There it is. Okay, those are the big bad guys. Again, there's many, many more that you haven't heard of. Some more sort of famous ones, for lack of a better word. You got Kilimanjaro there in Africa. Again, everyone's background on plate tectonics varies a little bit, but you see Madagascar over there?
Mm-hmm.
All right, Madagascar is that little island off of the coast of southeast coast of Africa. I knew it was called Africa. Thank you, though. It's taking me a little minute to get there today. So what's going on here is actually a kind of a three-part thing that's still in progress. Africa is ripping itself apart. In the last 60 million years, India used to be part of Africa. And it has moved in a very, very, again, geologically speaking, that's really fast. It has ripped itself off, and the same process going on here that's ripped Madagascar off, okay, is currently ripping off. This is the East African Rift right here. It's a big rift valley. You notice there's this isn't the best map for it, but look at Africa later. You go through this whole dang continent, and there's hardly any water, and then you get over here, and there's just all kinds of water. There's a whole bunch of low spots. All right? So that is slowly but surely ripping itself apart. I grew up hearing California was going to fall into the ocean kind of thing. No. All right? But this stuff, yeah, maybe. You never know. Again, a half joke. Just like California is going to become disconnected. Anything south of the fault line, I am forgetting the fault line today. San Andreas, thank you. Anything south of the San Andreas Fault is connected to the ocean plate. Anything north of the San Andreas is connected to the continental plate. So as that's splitting apart, again, anything south of that line through San Francisco will eventually become an island. But we could kind of use as a model what's going on over here in Africa. Yeah, you had a question back there.
Before the continents split, if they were all together, wouldn't that have been just a giant mountain range? It looks like all mountains are.
So, if I could ask you to hold that question for a month and a half. So, yeah, what we'll see, what they saw, going back to Wegener and his theory of continental drift, again, 100-some years ago, one of the things he saw was that when we put the continents back together, like the puzzle pieces that you know and love, they did reform mountain ranges, yeah. Not only did we see that there were similar rock types and similar fossils, which indicated similar environments, but mountain chains would piece back together and reconstruct that as well. So I'm not sure if that was your exact question, but yeah, we certainly would see that happening. But you've also got to, it's not just as simple as sliding those pieces around. That's kind of where he fell apart in his thing, like those wooden block puzzles we have as little kids. It's a moving thing. So you're opening and closing ocean basins as that's happening. So it is a slight bit of an oversimplification, but we certainly use it all the time, the puzzle piece thing. But yeah, the mountains would go back together. Mountain chains would go back together. It's pretty neat the way it all lines up. So at any rate, we were talking about Kilimanjaro there. Mount Fuji or Fujiyama, another famous one. The whole east coast of Asia, from north all the way down through and then out into the islands, is just a disaster as far as plates go. There's so many tiny little plates in there, not just the big Pacific plate boundary, but that whole area is just a mess with volcanoes and earthquakes. And I'm sure any one person can live there their lifetime or part of their lifetime and not experience a volcano, but certainly earthquakes seem to happen with some frequency. What else is on there? Just worth pointing out again that the Hawaiian Islands are nowhere near a plate boundary. Okay, we have a special reason for them. We'll get to that soon. But nowhere near those. Krakatoa, I'm looking for it. But we're going to talk about also the Caribbean islands. All right. You've heard in your lifetimes there's been some earthquakes over there. There's certainly some volcanic activity over there. The Caribbean plate is fairly active. So Yeah. Yeah, lots of famous volcano. There's Krakatoa. Yeah, I see it now. Over there. So, mostly lined up around plate boundaries, though. Okay. So, back to the point then, the Cascade Range, you see it over there on the west coast of North America, is part of this circum-Pacific belt, this ring of fire. All right. It's just our little bit of it. Okay, milking that slide for all that it's worth. Yeah, in 20 some years, I've never been able to come up with a better title slide than that. Things you could make out of lava. Yeah, pretty pepper. I don't know that one.
Obsidian.
Okay. Okay. So, the flood basalts. This vocabulary word is technically flood basalts. This happens to be a picture of the Columbia flood basalts. From as far back in the image as you can see, down quite probably below the water level on this lake is all lava. What kind of lava is it? Well, yeah, all lava's going to be extrusive. Somebody else, what kind of lava is it? Ah, thank you. You could have gone two ways there. You could have said the title, which is, just want to remind you guys that lava is a basalt. And you also could have said basalt is, by the way, what? Mafic. Good. Good. We want to start, getting you guys mentally ready for that rock test. Anywho, from all the way up there to all the way down there, and believe it or not, this covers a good bit of 4 states, is all lava. All right, and that's why they call it a flood. This is out in the Four Corners area. All right, Columbia Plateau, I believe. So, Columbia flood basalts, and massive. We have several of these. If you follow dinosaurs a lot, we talked about dinosaurs earlier. The Deccan traps, which were over in Asia, I'm going to generalize and say. Back around when the dinosaurs were on their way out, when they talk about worldwide volcanism or large-scale volcanism, this is the kind of stuff that comes to mind. But this is just massive. All right, this is the earth cracking open and bleeding for hundreds, if not thousands of years. Okay, I actually don't know the date, the age on these guys. I should. Maybe I'll Google that one of these days and actually find out what states it is in, so I could give less vague answers to you guys. But just an amazing amount of lava. Just trying to picture that pouring out, let alone the amount of time that it took. So, flood basalts. Yeah, please don't overlook the obvious answers. It makes me weep just a little bit when we get to one of the questions on the next test, and I ask you, what size grain is sandstone made out of? And the answers are silt, clay, sand, and pebbles. And you guys get it wrong. So, again, sandstone. It's stone made out of sand. The flood basalts are made up of basalt. Okay. Not everything is tricky or hard in here. We do have a couple geologists aren't that smart, so we have to name things what they are sometimes. Yeah, they make up a lot of crazy words, but sometimes, yeah. All right, lava dome. You may recall the word lava dome from hearing the St. Helens video. Lava domes you'd think would be a good thing. In short term, I suppose they are. What a lava dome means is that basically that pool of fire down inside the crater has cooled off and sealed itself over. Yay, good, the fire's gone. Okay, now we can go down there, we can hike, so on and so forth. Good times. The problem comes in when the pressure starts to build back up again. If you've never shaken a champagne bottle and popped the cork on it, you've at least seen somebody on TV do that. Okay? You're kind of building towards that with these. Because this cools so... It cools in place. It literally grows. Remember, igneous rocks are growing crystal by crystal. So this thing is sort of growing, if not out of the sides of the crater, but into the sides of the crater. It's sealing itself up. All right? And this is actually kind of what happened with St. Helens. Remember, they talked about the side blowing out. The top of it had sealed itself off so well that it actually found a better weak spot in the side of the volcano. Because these things are all just particle board, if you think about it. They're, the rock version of particle board, just layer after layer of randomness piled on top of one another. Sometimes it's ash in chunks, sometimes it's nice smooth flows. So they're not the, I don't say most durable things, but oftentimes these domes can be more durable than the sides of the mountain. And then what happens when it blew out the side of the mountain, the top crumbled down, they had the landslides. So it wasn't just, the volcanic effects coming out the top, but you had the collapse and the crumbling down as well. So lava domes, not so great. And we're going to refer back to these a little later on when we talk about some gas features, all right, which I suppose is where I should move the blue lava to, the gas features. So lava dome, again, when the top of the volcano sort of seals itself off, the eruptions are, gone for the moment. There's no pressure anymore, so on and so forth. It starts to cool off, and it seals itself up. Eventually, it makes a nice pointy mountain, grows snow and trees and whatnot. But it can build back up, geologic time-wise speaking. All right, columnar jointing. And this is reminding me that I had some more pictures that I was supposed to add to this. I'm not going to stop today and do it, though. But if I do it before we talk again, I'll add those as well. So I'm going to leave it on this slide for a second or more, too, and then I'm going to show you another one. And I think we'll come back to this one. A buddy of mine was just here. And, well, this is a very nice picture I borrowed from Flickr, whatever that is. I've got some real ones. And I want to point your attention, where's my mouse? There's mouse. To what's going on over here, and you see those various posts. And this right here may likely, you never know, because again, they never used to label pictures that well. Oops, wrong way. What we're looking at right here, all right? So, columnar jointing refers to those hexagonal sort of telephone poles pieces that we're breaking off. Joints are breaks in geology, fractures. All right, a joint in the rock is a crack in the rock. So what happens is that this is way down below the surface. This, I think, is my picture. Again, I can't prove that, but I was there, and I know I took a pretty damn good picture while I was there. There's signs there which have been lost to time, unfortunately. I took this back in the days of film cameras. The ground level was well above the top of what's that tower now, okay? So this is what they call a volcanic neck. Remember we drew a vent pipe, and then we had that magma chamber down below it? When we're seeing this stuff, we're somewhere below the volcano, but before the magma chamber, okay? And so time goes on as it will, and sedimentary rock is nowhere near as durable as igneous rock. It just isn't, okay? So all of the surrounding structure has worn away, been eroded away by time and weather, and so on and so forth. So what happens then is that slowly by surely, with the pressure release, this starts to fall apart, peel apart. somewhere between a bloomin' onion, all right, you remember those, and self-peeling string cheese. We can bring this metaphor around here. So it breaks or fractures in this manner. Now, why? How? Well, we touched on this very briefly. Remember when we talked about minerals? Crystals, when we talked about minerals, and I said that, you know, the crystals' shapes can't help but have an effect on the structure as a whole. Think about building with your Legos. Everything's a cube or a slightly little slanty thing because that's what you're building with. Early computer graphics, the same way. Okay? Well, crystals are sort of the same way, and what happens is these things align themselves in such a way, I can't explain the chemistry on it, but that this rock type fractures into these sort of pieces. It's almost like cleavage, but it's not. Okay? To go back to, again, another mineralogical word. So columnar joining refers to the fact that basalt columns tend to fracture off in these hexagonal, like I said, sort of telephone pole looking things. Some of them are quite famous. Devil's Tower is one of them. The Giant's Steps, the Giant's Pillars, I'll show that in a couple minutes, out in Ireland is another one. Before I leave this slide, though, I want to address the rock hammer laying there in the middle of it, because so many people go through lives thinking that geologists are horrible photographers. Why did you get that hammer out of the way? Well, somebody tell us, why didn't we get the hammer out of the way?
Scale.
Yeah, all right. It's there for scale. And being a geologist, well, a non-practicing geologist, but being a geologist, I know that is the short hammer. That's Estwing. Anytime you see the blue hammer with the yellow label on it there, that's Estwing. It's a really good hammer. Apparently bricklayers and love them as well. They make regular hammers too. You ever see one at Home Depot? Small plug for Estwing. I'm not supportive of them by any way though. But they're great hammers, okay? I know that is the short-handled one. So I know that it's about yay big. For those of you at home, I reached my hands out to about 12 inches or so. So we now know the diameter of that thing. All right? Now, in most of Japo's pictures, you got my foot in it because I always forget my rock hammer doesn't travel around with me anymore. My son spilled chocolate milk on it at some point in time, and we didn't know, and I found it all nasty and rusty because it was under my car seat. Protection and rock hitting. But ever since we cleaned it off, it never managed to get back into the car. I should work on that. And they give us these little scale cards at all the conferences, too. Very nice little 3-inch scales, broken down metric and American. And we've got stacks of them sitting on our desks and our drawers, but again, they never make it out to the field with us. It's just a great way of making notes without having to take rocks home. We still bring rocks home, but we take the picture for the notes, and then we hopefully match it back up to the rock in question later. So columnar jointing, Devil's Tower's out in Wyoming. Lots of cool stories about Devil's Tower. My generation knew it as the thing that the UFO landed on in the end of Close Encounters of the Third Kind. And the guy made it out of mashed potatoes and everything. But it's been around, and we've been infatuated with it ever since we went out west. The Native American story is that a giant bear chased one of the Indian chiefs up there, and those are his claw marks as he tried to jump up and get him at the top. So a little bit of Native American folklore. Everybody makes up stories about what they don't understand. We're still doing it these days. So, very, very cool story. And that place is absolutely infested with prairie dogs. They're everywhere. One ran right across my foot, totally freaked me out because I was wearing a pair of sandals at the time. But they have the, they don't call them enclaves, prairie dog. They're communal livers at any rate. Colony. Yeah, I think, it might be colony. And again, I've got pictures of all these. I just got to find these pictures one of these days. This is like 93 or so. No, 95, 96 actually. I was out of college. I was in grad school. So, actually, maybe it doesn't matter. Mid to late 90s, a long time ago. So they're somewhere in a box. But, so very cool stuff. I have a video on it. I haven't showed it in years. But it's a neat place. And it is literally the middle of nowhere. It's like an hour and a half from the nearest highway kind of thing. At least it was in the 90s. Giant's Causeway. There we go. I was close. I like the stack in the back because it reminds me of a video game I used to love called Cubert. But very cool. You could walk right out here. If the oceans haven't worn it away, I guess they're of the mind that a handful of tourists aren't going to ruin it either. So very, very cool area. And while we aren't quite there yet, this sort of, and this as well, starts a theme that's going to be common through basically the rest of the semester. That, as we half joked earlier, dinosaurs didn't have thumbs, they couldn't take notes, so on and so forth. All we have to reconstruct the past are the rocks. Occasionally we're lucky enough to get a fossil or something in them that gives us some biological evidence on top of our physical evidence. But when we see those basaltic rocks, when we see this thing that we're going to talk about called a lava tube, even if right now there's no volcano anywhere nearby, we know that at some point in the past there had to have been. All right, and it's sort of like our own little version of CSI where we reconstruct stuff. Again, back when I was growing up, you had these pitiful dioramas behind the dinosaurs. They loved to put the bones in some sort of context for people. And I get it. That's very cool. But a lot of times that wasn't based on a whole lot, okay? Or it was based on misconception. But that whole area has sort of grown up a science around it of reconstructing those environments, paleo-environmental, okay? Paleoecology. Just throw paleo, which means old, in front of any of those words, and you're pulling that stuff out of the rocks. And that's sort of where my mindset is. I'm a historical geologist. So when I was fumbling through minerals and whatnot with you guys, all right, my brain is elsewhere. So back to lava tubes. And that's going to go, especially in sedimentary rocks, you're going to hear a whole lot about reconstruction and environments and stuff like that. All right, so lava tubes. Lava tubes basically happen when lava flows into water, okay? And because it hits water, the outside cools very, very, very quickly and sort of makes a straw or a pipe that the lava continues to flow through. And then as that fresh lava flows out, it crystallizes on the outside. It's sort of a self-building pipe structure, to go back to that Windows screensaver we talked about a while ago. All right? Not quite as creative as that one is, but that's the idea here. Those paper, they call them yo-yos. They weren't very yo-yo-ish, but those paper yo-yos wrapped up on a stick that you'd get as party favors as a little kid. You know how they shoot out and then come back. All right? Again, sort of along those lines. So this, again, whether it currently is or isn't, had to have been near a fairly large body of water. So not only did we need a volcano, but we needed a large body of water. I don't know. To me, that little bit of light in the background and the way the rocks are just sort of piled up, that does look sort of coastal back there. I know it's just a glimmer there of some light, but I think that they're at a coastline now too.
I mean, there's also water.
It could have been rain, but yeah, I pondered that. Could have been rain. So again, we have a random tourist standing in the way, or we have a geologist there for scale. Humans aren't great because as you look around the room, you realize that we come in not only all shapes, but all sizes. So people aren't the best guide. You'll see lens caps, pencils, rock hammers, but we've got a person here. This slide is great for one other reason. It hasn't come up too much, but one of the things that runs through a lot of our conversations in science is how technology has changed things. And this is a great incidental example of that. Again, this is one of those slides that I've had forever. And back in the day, it was either overheads. You guys know what overhead projectors are, even? Okay. You had Elmos, which is kind of like Elmo was an electronic thing. The teacher could put a book under it and project that. Overhead projector actually had to have clear sheets of paper with this blinding light. When the teacher walked in front of it, they'd always blink. So we either had that or slides. I hated slides. You had the carousel in the back and you have to click it. So I was always an overheads guy. At any rate, I've had this that long. At some point, and I'd always talk about that line, whether you guys asked about it or not, I'd talk about that line going through the middle. So I used to say, well, you know, we're seeing the effects of weathering and erosion. The waves have come in and worn down that rock. That gives you an idea of where tide level is, blah, blah, blah. I made up some crap because I didn't know what it was, but I'm a teacher and I'm supposed to say, you know, what's going on. One semester I walk in, we got a new projector, whatever. I realized that that's a ledge out that you could set a coffee cup down on or whatever. For 15 years, it looked like an indent because of the quality of the projection. So all of a sudden, I had to change my story. Now that's a ledge, not an indentation. So I still don't know exactly what's going on here, but my guess, and looking at how smoothly rounded out that top is, not, again, that it couldn't flow through on its own, but my guess is that this was sort of augmented for tourists. The bottom was dug out. I doubt it was blasted out because that's kind of hard to control that, but you would have ruined the roof, I would think. But I think that's just they cleared out a path so people could walk through it a little bit there. The other thing is it could have just been a natural lava line, so to speak, kind of like that layer left inside your bowl of pudding or something if you don't scrape it clean. But yeah, so for years that looked like an indentation. And then we got a really good projector one year.
From where I'm sitting, and I don't know if everybody on that side can see it, around the corner on the left-hand side, you can see it comes out quite a bit.
Oh, I know. But like, just trust me when I tell you that was not evident for a very long, for a very long time. That was not evident at all. So, wild stuff. And those were the coolest boots to have, by the way, at the time. Buckskin with the red laces. Every so often they'll still show up at like Walmart or somewhere like that, but those were the very cool geology boots. And this one, probably not a random tourist because I don't say nobody would notice these shapes in the rocks, but more than likely this guy's there. Either his buddy, his wife, his girlfriend, somebody's a geologist dragging him along. Again, we don't know how tall he is. He looks kind of tall, though. So we can't use him for scale. What he's looking at are those circular sort of blobbish things there. If I had named these, if I had been the first person to find them, I would have called them beanbag basalts. Not only because I like alliteration, but I like beanbags. Can't get out of them anymore, but I used to love them. Then they're about that size as well. These are kind of big for pillows. So what happens here is that we've got sort of the jacuzzi effect, the hot tub effect. All right? You're underwater, and you've got a magma vent that is coming out. And I can't tell you the depth off the top of my head, but the depth is pretty great. So much so that when the lava comes out, it sort of, pardon the term, it sort of pinches off the lava, much like the air coming out of a jacuzzi makes a bubble, okay? And it rolls off to the side. More lava comes out, it pinches it off into a little ball because of the water pressure, rolls to the side, and these things just pile up around the vent. We don't see that happening on land because you don't have the pressure to make these shapes. So again, whether or not he is at a coastline right now, and more than likely he is, but what this gives us then is some insight as to previous water depths and so on and so forth. Now, there is such a thing called uplift that can move the rocks up. We don't just have to bring water up and down. Sometimes there can be uplift. And before you go spouting off what you think is going on, you should always check the history of, what we already know about that area. But just at a, cursory glance walking by it, you could use that as a gauge to, well, this area used to be underwater. As I said, that doesn't always work. At the top of Mount Everest, going back to India, okay, India is smashing into Asia very, very quickly, making the Himalayas. Heard of them? All right. The top of one of their tallest mountains there, the tallest mountain there, I think, is a band of limestone. Limestone is only made under the ocean. So that is a great example of what uplift can do, okay? So we never want to discount that. But when you're at an existing coast, all right, it's a fairly safe conversation starter. So pillow basalts only form underwater, and a decent amount of water at that, because you have to get the pressure, because it's not just air that you're making bubbles out of, it's magma, lava, right? That's a good bit denser. So we need a decent amount of water pressure here to form these things. So you see how this really is just things you could make out of lava. Well, it is kind of a boring title. It's quite fitting. All right. If you remember one of our earliest slides, we talked about the three things that come out of a volcano. And we mentioned lava, and we mentioned pyroclasts, and we mentioned gases. Well, we're caught up to number 2 of those right now. We're going to talk briefly about pyroclastic material, which is arguably lava that just splatters, okay? But it is its own thing. We have 3 sizes of pyroclast. Again, I don't have a slide for this, so do please write them down. We have ash, cinder with a C, and block or bomb. Ash, cinder, block, bomb. I used to teach in a lecture hall, and I had one semester, one kid raised his hand way in the back. Did you say bomb? Like, yeah, that's where bombs come from, volcanoes. So the difference between a block or a bomb is angularity, okay? Blocks are, again, you guys don't really care, but just telling you why we have a thing there. Bombs are going to be more irregular. Yes, sir.
BALM or BOMB?
MB.
MB.
Yeah. As it probably comes sailing at you like a bomb. Yeah. And according to Hollywood, at any rate, they whistle as they're coming through the air, and all that fun stuff. So these are probably along. Again, you see the penny for scale. Okay. These are probably along the lines of what I would call cinders, because they know no boundary. Again, Mother Nature can move whatever she could move. I still remember the guy in the St. Helens video, if for no other reason than I've watched it, 100 times. But he talking about Volkswagens, and he gets all excited. He says, "Ooh, see that one?" He says, "The size of a small Volkswagen." I don't ever remember big Volkswagens, sort of the microbuses, but yeah, I mean car size. So if block or bomb can go up to car size, I think we're safe calling these things, cinders. But it just gives you an idea. And going back to block or bomb, these are the more irregular shaped things that I was talking about. Ash, of course, is ash. And ash could come in all shapes and sizes as well, but we're familiar with it. So ash, cinder, block, and bomb. And that's, a size thing, a diameter thing. I'm sure there's numbers in your book. I don't need you to learn them. You don't need to learn them. But ash is the smallest. Blocks and bombs can be as big as, it's like saying boulder. There is no end size to boulder. And this happens again, as I said, when the lava just gets splattered. Usually, again, due to gases. All right, gases are a huge part of volcanics, and just imagine you're cooking some sauce on the stove or something like that, and as it comes up and bubbles, it splatters. You get some splashes here and there. It's the same idea, but oftentimes with much greater, force. So we saw the ash in the St. Helens video, and there it was really just a nuisance. Okay. Again, a buddy of mine, my friends travel way more than I do, sadly. I've seen a good bit of America, but I've not left the continent yet. So he had an opportunity, I guess it was 2 years ago now, took his family over to Italy and poked around, and they went to the Pompeii area. So we've all heard about these guys. All right, you've seen one or two maybe in a textbook. Maybe you saw something on the Nature Channel. I don't know. But he had some great pictures to share, so he allowed me to use them. So what basically happened? This is replacement. Okay, a lot of these people were buried alive. If you don't know the story, it was a whole lot of ash. It was, I think, very early in the morning, and it caught a lot of people way off guard. Apparently, the Vesuvius gave little to no notice. Pompeii is the city. Vesuvius is a volcano.
Well, where would you run to? It's like Annie.
Well, there's that too.
Trying to get out of here,
Yeah, there's that too.
But
But no, I think the fact though that so many of these people were caught in sleeping poses, and there's old stories about the Romans and standing at their posts as they slowly got buried by ash. I think even the most stoic Roman soldier would have run, But you never know. You never know. Poor little donkey here. But just some of the preservation is amazing. Yeah, and I can't help that there was a little bit of artistic as these people were prepping them up. The fact that we're seeing the ribs on this one gentleman here. Maybe the person...
Is that a dog?
Donkey, I think.
They made tabs from off them, right?
Huh? That's a great question. I can't imagine, although they're behind glass. But yeah, I mean, they themselves are cast. So... But you would, like this one doesn't look like he's through glass. But that guy does. Maybe they treat human remains in quotes, different than the animals. I don't know. But yeah, and I remember when I found that out with going to see the dinosaurs, even at the big museums. Like that's not the real thing. Sorry for the child.
oh, that's a baby.
All right. So, ash can be more than just troublesome. So I don't really have, as I said, a section for gases. We did talk about the three things that come out of a volcano, and I guess now that we have the sulfur thing, maybe I can make one including Nuit Ardente. All right, Nuit Ardente. Supposedly, that is French, I believe, for glowing cloud. All right. I prefer flaming cloud of death, and I don't know how you'd say that, but put Muerte in it somewhere. But this is way too Disney. These things are horrible, absolutely horrific. Remember I told you we'd come back to the lava domes, right? Now they could seal off a volcano. So as the pressure starts to build up, again, that's gas. That's what's building up the pressure. Yeah, there might be magma pushing, but along with that, you've got these gases. And these gases are embedded in lava. So they're boiling hot, and all kinds of nastiness, okay? Sulfurs, carbon dioxides, carbon monoxides, just anything and everything, methanes. It's all building up under there. And what happens if you'll pardon the term, this is sort of a volcanic fart, okay? That this pressure builds up, and I suppose it's better than the whole side of the mountain collapsing and rumbling down, but you'll just get this huge, I'm going to call it a steam release, but again, it's not all water vapor. There's a whole bunch of nastiness in there that shoots out the side of the mountain, and because of its density, it's way heavier than air, okay? It just kind of trucks on down the side of the mountain, the volcano, obliterating anything in its path. The fact that it's poisonous is really kind of secondary to the fact of, or even tertiary perhaps, to the fact of how hot and how fast this thing is moving. Oh, that's a Lahar, so I don't want to go there yet. Do I have a new air dente? There's possibly one there. Okay. This one's rather dramatic. But a lot of times you hear, again, these stories of these villages and towns around these volcanoes, and there wasn't even an eruption, it was just the gas that snuck out at night and killed everybody. It doesn't have to be this massive thing sliding down the side of a volcano. Okay. Again, these gases are heavier than air. They kind of linger down low to the surface. And, well, if it happens at night while everyone's sleeping, or any of the animals that are dead on the ground, again, Hollywood likes that one. You start seeing all these critters littering the forest floor and everything. But yeah, New Air Dente. It's this boiling hot cloud of ash and gas that comes trucking on down the side. Hundreds of miles an hour. Again, thousands of degrees Fahrenheit. Miserable, nasty things. And then Lahars. Lahars seems like it's plural, but it's not, apparently. I've never had a good translation on this one, but essentially a Lahars is a volcanic mud flow. And again, if I felt like putting some more slides in here, I mean, I'd love to put more slides in here, but I don't want to do it to you guys. It's such a long PowerPoint already. One of the things I'd put right now is that before and after image of St. Helens. All right, remember that opening picture of Mount St. Helens? That sucker was stark white, right? Because it was absolutely covered in snow. And then once that eruption started, of course, all of that snow melts. Okay? Now, up there, you're above the tree line, so you're not talking about anything but snow. But what's right below all that ice cap, or that snow cap, whatever you want to call it, that's where the soils, the trees, everything. And as that water comes down, it brings all of that with it. Not to mention you've got the ash poofing out the top. And you just get this slurry, all right? And while it is a whole bunch of things, we call a lahar basically a volcanic mud flow. It's a lot of stuff. And they talked about, while they didn't use the term lahar, all right, they talked about this. This was one of the big issues that they had with St. Helens. Okay, these mud flows clogging up the rivers, the ash, they called them ash flows. And the term is escaping me at the moment, but your textbook will refer to another rather similar term to these. And kind of use them interchangeably. Now this is kind of intriguing to me because that's either going to be snow or a whole lot of really white ash. So I'm not sure what's going on there. But the mud flow obviously is quite brown, but the fact that there's so much snow and ice left on that mountain, I don't know. It's a really cool picture. I just found it semester as well. Yeah, but just, again, this is one-sided as well. But, remember St. Helens only went out the one side. And I can't conjure the exact image in my head, but I know that most of that snow top, well, it collapsed as well, but most of that snow on St. Helens left. That's a lot of snow left. So I don't know if we're just seeing reflective ash or what's going on there. Again, it would help with some context as to what volcano it was, so on and so forth. All right, we just got some catch-all slides here at the end. I do not want you drawing these things, but just some reminders, I guess, of some stuff we talked about ways back. So this is a shield volcano, all right? And what we're looking at here is a very, very, very low angle, gentle slope. We kept our drawings very simple with just a central vent pipe. All right, this has multiple feeders, and that's okay. They talk about lava fields when you hear, if you're watching a video where someone's going out on a volcano, lava field here, lava field there. These things are massive. Okay, we drew a very oversimplified volcano for you. So you could have parts that are active at the moment, while the other side of the volcano, which is arguably a couple miles away, is completely inactive, and you could go wander around there, so on and so forth. So, shield volcano. And for comparison, cinder. Now, what I don't like about this one is that they say lava flows. Well, no, we just spent all this time telling you that cinder volcanoes are made of pyroclastic material. They're made of ash, cinder, block bombs, so on and so forth, pyroclasts. So why use the word lava here? But I keep it for the picture more so than anything. The contrast from this to that. And then while I don't have a picture for it, remember that our composites, the third type, mixes the worst of both of these, the best of both of these, however you want to say it. So we have this massiveness of the shield with the elevation and the nasty sputteriness of the cinders. We're talking about St. Helens. Again, this is sort of what was happening there. We told you the side blew out. And consequently, then the top crumbled down, which is why they had such a huge elevation loss off the top of it. And basically that lava dome at the top was it was just a lot easier for it to blow out the side. They're putting some potential groundwater in here as part of maybe what helped build up some steam. That's an interesting thought. Rocks are old, they're cracked. They're leaky for sure. But that's a neat idea. And so again, this is why it was directional, okay? If that thing had gone out the top, you would have been hearing about a lot more towns in that video. A lot more area would have been affected. I can't remember which slope, if it blew out. I want to say it blew out to the east, but mostly, I guess. I really need to remove this slide. It's pretty, though. All right. So I think this brings us to our conversation about active, dormant, and extinct. And mainly, it's an argument, so to speak, on whether or not we should use active or dormant, because dormant means resting, sleeping, right? Well, on whose time frame? On whose time scale? So active, as I said, generally speaking, we say in recorded human history, in our time that we've written down, we remember. If we can remember it happening, we're still going to call that active. Well, where does that leave dormant? Well, without a whole lot of heavy monitoring equipment, it makes a big gray area. And extinct, I give you Wizard Island. So Wizard Island is in Crater Lake. Crater Lake is in the Cascade Range. It is either extreme, I think it's extreme Northern California. And it is a caldera. Okay? Most of the mountain's still there, but Crater Lake is a caldera. And it's filled up with water over the years. So it's a very pretty lake. But right in the middle of it is this little island that sputters and spits and glows at night when it's erupting and probably smells quite nasty. And I'm sure many, 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 many moons ago, the folks that lived there probably had another word for wizard, okay? And they said that's where the crazy old wizard lives. Don't go out there, kids. Don't take the canoes, so on and so forth. But over the years now, like I said, we call it Wizard Island. And what's happened, you've been staring at the pictures hopefully while I'm talking.
All right, you see that the magma chamber collapsed and formed the original caldera. And again, time is irrelevant almost in these slides here. At some point that had to fill up with water. And what they're showing here is that one of those old vents just became active again. So my point is that even after a volcano blows itself to smithereens, damn thing's still going. So that's why I don't like those active, dormant, extinct conversations. Because you'd think if it blow itself up. Now, Devil's Tower. Well, okay, maybe then. Okay. So, and going back to Yellowstone. Yellowstone is a caldera. There was a volcano there at some point. And it's still going. Again, it's not making a big pointy mountain spewing out ash and lava, but it's boiling up thousands and thousands and thousands of gallons of water. Soufriere Hills. This is in the Caribbean. And, we talked about just a couple minutes ago, half jokingly, what were those people in Pompeii going to do? This guy maybe was visiting the next village over, or he's from the next village over.
Based on the population of the Caribbean at the time, I'm assuming he's a slave, because the French had slave colonies down in the Caribbean, probably when this happened.
Could be. Could be. My point more so is that he's not dead, but he could be a slave. So it takes a moment or two of staring at this to realize that was a town.
Village, if you would. Here's the road, right here. Here's the shoreline. These are your docks. So all of these structures were, homes, businesses, whatnot. This place was level. So whether he's from a neighboring town or whatever, or did manage somehow to get out, he's surveying this damage. This was early 1900s, 1900 something. We had cameras, so it couldn't have been that early, but a long time ago. And I've got a video that I haven't seen in a long time. I'm not even sure which one it is. But goes down Montserrat area and talks. The area still hasn't recovered. Okay, still hasn't recovered. It's most of the people have left. They've built the town back up, but it's just a constant low level ash and gas. That's quality of living is, and you're left with the people that can't leave, basically, that are living there. So
even more so, that area is known for its low poverty level
yeah.
because the French never helped with reconstruction of the homeless rates.
yeah, and not a whole lot of opportunity for industry, even if they had some money there. It's just they probably had some crops and whatnot. But
So after all that, I like to end on
sort of a nice little. Yeah, we talked here and there about a fountain at a mall or Disney doing something, and this seems like a very Disney-ish sort of volcano forming here. What kind of rock is that?
Basalt.
Basalt. Thank you. Yeah, why? Because it's black. I know it's shiny. All right. So but it's probably not obsidian. But yeah, so that's some basalt in the background there. Nice, pretty little thing.
I actually have one more thing that I do want to show you. And I talk over and over again. We have time, believe it or not. It's not even...
10:57.
yeah, I have 3 minutes. Give me it. Because you guys won't watch this, even if I tell you to watch it when you go home. Now, you folks at home, I don't think that this will translate through to you. So please do follow this clip. Let me see if I can... If I shut off PowerPoint. Don't worry about it. We'll get it later.
Creators, take these 3 apps I built to run my business made with Base 44. They're ready for you as free-to-use templates in the link below. Let's talk.
Oh, you guys still aren't even seeing it. You got to tell me that. Hold on. You guys probably are seeing it on the laptop, but the folks in the classroom aren't seeing it. Okay, let's try this. Don't replay it. Just play. How about play without replay? Oh, for the love of Pete. And they both died one day while doing that exact same thing that guy was doing. So I like to think at least they went out together on that one.